In this video, we will be graphing square roots and radicals, and our objective is to graph the square roots and other radical functions. So first, I want to discuss families of graphs. We, in the past, have already discussed linear graphs. They are straight lines. We have also looked at absolute value functions and what they look like, which we talk about B and V's. And we've also looked at power functions. Now, I normally do not call it a power function. Normally, we call it a quadratic. Because x squared gives you a parabola. However, if you notice, any x that's raised to an even number, so if you had like x squared or x to the fourth, x to the sixth, x to the eighth, x to the 10, they are all parabolas actually. If it is an even number, you are going to get some type of U shape. Now, if the power is odd, then on the right, you're going to have it going up. But on the left, instead of it going up like it is over here, it becomes the negative, because when you have a negative raised to an odd number, it actually becomes negative. And negative raised to an even number becomes positive. And so that is why if it is an even number, then it will both be going up. But if it's odd power, then one side goes up, the positive side goes up, but the negative side actually turns down. So these cases would be like x to the third, x to the fifth, x to the seventh, x to the ninth. You get my drift. Radicals actually kind of do the same thing. If you have an even radical, so if you have like a square root of x, or you have a fourth root of x, or a sixth root of x, then it is only going to start at 0, 0, and it is going to go in the positive direction, because you cannot take the square root of a negative number. You can take the cube root, though, of a negative number. You can actually take the cube root of -1. It's actually the number -1. So if you have an odd radical, like cube root, or fifth root, or seventh root, then it is going to take on this shape. It is going to look like a square root, but because it's odd, you can have the negative as well. So you need to memorize what these different families of functions look like so that you will know how to transform these functions later. You're going to start with, we've talked about in the past, like a vertex. So you're going to start with a vertex here, or in this case with the absolute value of vertex. With a square root, the vertex starts at 0, 0. The same thing here. You're going to take that vertex and be able to move it up, down, left, and right, or flip. So transformations. If you take an entire function, and I'm just going to call it a function because you could take the square root of x, you could take an x squared, you could take a fifth root of x, you could take a fourth root of x, any function. If you were to add a number to the outside of the function, meaning it would be x, the square root of x plus 4, not the square root of quantity x plus 4. These two are different. If the number is on the outside, then you take the entire function and you would move it up. If it is a minus, you would take the entire function and move it down. It doesn't matter if it's an x squared or a fifth root of x. You move it, you're just moving the entire thing up or moving the entire thing down. If you have a number that is inside, attached to the x, first, you would move it left and right, but in its opposite direction. Positive means you actually move it left. Minus means you would actually move it right. So it would look something like x plus 4. The 4 is attached to the x, and then you would take the square root. This is where you would move it left and right. This is a positive, so you would actually move it left. Or if you had a fifth root, and I did x plus 2, as opposed to x to the fifth plus 2. Here, you would move left. If it was a positive, you move it, left. So in this case, it's a positive, you would move it left. Here, the number is on the outside of the function. If you notice, the function is raised to the fifth, and the 2 is on the outside of that. So in this case, you would move it up. So do you see the difference of when the number is attached to the x and then when a number is on the outside of the entire function? Now, if you have a negative that is on the outside of the square root, it reflects. Basically, you flip it vertically. So instead of it being going up like that, you would actually make it go down like that. So it reflects across the x-axis. You just flip it. If the negative is on the inside, so if you had the square root of x on the outside, and if you had the square root of x on the inside, these are two different graphs. This one means you would be flipping it up and down. This one means you would actually be flipping it left and right. So what this would look like, instead of it going this way, it actually would flip that way. If you have a number in front of the function, you're going to stretch it. And if you have a number inside the function that's multiplied by it, it's actually going to compress. So for example, let's say we have some function. We don't know what it is. Maybe it's an absolute value. Maybe it's a square root. Maybe it's another type of radical. It doesn't matter. We can still say what the function would do. So in this case, the 3 is on the inside, so it would move left 3, and then the negative 4 is on the outside, so it would move down 4. In this case, the negative means that it would flip, or I guess you would say it would reflect across the x-axis because you're flipping it over the x-axis. And then the negative 2 means you would move it right 2, because negative means you actually go in the right direction. And then the plus 1 means you would move up 1. This negative is on the inside, and so it would reflect across the y-axis. And then this 3 is on the outside of this function, and so you would move it up 3. Not left or right, because the 3 is not inside the parentheses. You would just move it up 3. So I would be really careful, now that I'm thinking about it, to not use the word flip, because it depends on which way you are flipping it. So you need to discuss it in terms of reflection of whether it's across the x-axis or the y-axis. So for example, let's say they have a function. In this case, it's an x squared. And they have transformed this function from its parent function, which is what they would necessarily call the when you start at 0, 0 is the parent function. And they're moving it over left and down. Now, first, did they reflect it across the x-axis? So like, is it going down? No. So it is going to be a positive. That did not change. It moved left 6. And so therefore, you would actually have the opposite. Normally, it's a negative 6, but you take the opposite sign. So it is the x plus 6. And then they moved it down 2. And so it would be a negative 2. And it did match that function. So let's do another one. This is a square root of x. You start at the parent function, and then you're going to get to the dotted, what the dotted line creates. So one thing I noticed is that it did flip, it did reflect across the x-axis. So we know that there is a negative in the front. Now, it went to the left 4 and up 5. So left means that it actually went in the opposite direction. So that's why it's a plus 4, because it's the opposite of a negative 4. But it meant up, which is exactly what it did. Whatever it says to do up or down, you actually do that, which is correct. It does match that graph now. So if we do a new problem, again, we have an x squared, but we notice a couple of things happen. One, we notice that it reflected, so it is negative. And then we also know that it moved left 2. Since it went to the left, it should be a positive 2. And then it went up 5. So it went up 5, which does give you its transformation. And again, one more. We notice that it did reflect, so it is a negative. It moved right 2, so it should be the opposite. It moved to the positive 2, which means you need to put in a negative 2, which is why that becomes x minus 2, is because it went to the right. It's the opposite. And then it went up 3, So I put in a positive 3 for going up, and it does match the new transformation. Now in this type, it wants to know which of these functions represents the new transformation. So in this case, we know it's an x squared, but at that moment, it doesn't matter because it can be any function. So we notice that it reflected across the x-axis, so we know it's going to be a negative in the front, which they all have. And it also went left 4, so it's the opposite of a negative. So it went to the negative 4, but you use the opposite, so it should be a plus 4. So it's either going to be the first one or the second one. It is going to be the first one in this case because you moved left and right, which stays inside the parentheses. This one would have been the fact that we moved up or down 4. So because we went to the left 4, it should be a positive 4. So in this case, this happens to be an absolute value. We moved it down and we moved it left. And so moving left means we're going to take the opposite. So we went to the negative 1, so it's actually going to be a positive 1. So it's either going to be these two, and then we went down 3, so the answer should be this one. Going left 1 means the opposite sign, and then we went down 3, so it should be that one.